We're going to work through problem 4.15 from Taylor's Classical Mechanics, Chapter 4. This is a problem using the gradient of a potential function, and we're going to estimate the change in the function if we move from a point R at 1, 1, 1 to another point at 1.01, 1.03, and 1.05. So we can call each of these changes, we'll just start by calling each of these changes our x. These are our x, y, and z. This is x plus dx. This is y plus dy. And this is z plus dz. So if we subtract off our x, y, and z, which is just 1 from each of this, we get dx equals 0.01, dy equals 0.03, and dz equals 0.05. These will become important in just a moment. So we have an approximation. It's saying to use formula 4.35, which is an approximation, which is df equals the gradient of f dot dr. Which we know is the gradient of f dotted with dx, dy, dz. Alright, so first what we'll do is find the gradient of f, and f is equal to, let's just start with that. Let's write out our function here and take the gradient. F is equal to x squared plus 2y squared plus 3z squared. Now we're going to go ahead and take our gradient of f. If you're not familiar, I do have a video on taking a gradient. So take our gradient of f. The x component is going to be 2xi. Y component is going to be 4yj. Z component is going to be 6z. Okay. And we need our gradient dotted with dr. And that's going to give us our small change in f that we're estimating here. It says to use this approximation to estimate the change if we're moving from one point to another. So, and after this, we'll compare it with the exact result, which has another method. So what we're going to do is take our 2x dx plus 4y dy, this is going to be our dot product, plus 6z dz. Now we're going to end up with 2x times 0.01 and plus 4y times 0.03 plus 6z times 0.05, and this is going to be 0.02x plus 0.12y plus 0.3z and our x, y, and z are 1, 1, and 1. So at 1, 1, 1, it's 0.02 plus 0.12 plus 0.3, which gives us, that's going to be 0.15, 0.17. That's going to approximately equal our small change in our function in moving from those points. I actually see now that I added that last term right, so we will instead end up with, or added it wrong, we'll instead end up with, that's going to be 42, 44, 0.44. It's going to be our approximate change in our function. Now the exact method, this is our approximation. Exact method is going to be to take the function at those points, which was 1.0, 1.03, and 1.05, and subtract off the function at the original point. To get the actual change in the function between those points, just by taking the final value, subtracting the initial value, that'll give us the change. Now let's see, throwing this into a calculator and see what we get. And this gets 6.4494 minus 6. This is coming from there. The 6 is coming from our function at 1, 1, 1. And this gets a 0.4494. So you can see that the approximation was not very far off. And for a sufficiently small change, it would be even closer.